Okay, well, now we know how to use a calculator. We're going to do something slightly different. Here, section 2.2 on page 135 in the book, 143 if you have the PDF. And the PDF, of course, can be downloaded from the site. It's in the syllabus. Go to openstacks.org and you could download the Calculus Volume 1. We are going to talk about the limit as a function. So let's talk about this limit idea, and it's a massive deal in calculus. And I'm going to start with an example. We kind of did it before, but we did it for the slope of the tangent. Here, we're not doing it for a slope of the tangent. We're doing it at a value. So let me start with an example. Let f of x equal x minus 1 over x squared minus 1. We want to find the limit as x. We want to find the limit of f of x. We want to figure out what is y approaching as x approaches 1. So if x approaches 1, we're going to do kind of what we did in the previous section. We're going to pick values for x. Before they picked it for us, we're going to pick few. So 1, we're going to go above and below. Let's go above. Let's go to 1.5 and figure out what 1.5 minus 1 over 1.5 squared minus 1 is. Then closer to 1, 1.1. Closer to 1, 1.01. Closer to 1. And let's see if we need more than that. If we need, we'll go on. The goal is to figure out, as we go down, these numbers are leveling off next to what value. We want them to be very close to each other. Then we're convinced that's the number. So, as you see, here we have x minus 1 over x squared minus 1. When I say 1.5, you can take 1.5 minus 1 over 1.5 squared minus 1. When I say 1.1, you're going to say 1.1 minus 1 over 1.1 squared minus 1. So you notice, this is the value that's changing all the time. Well, it's no big secret. It's always the x. So if I go to my calculator straight from the very beginning and say, let's start with 1.5, I could save myself a lot of work. That's stored in my answer. And now if I go parentheses, my answer minus 1, that's going to take 1.5 minus 1 divided by my answer, which is 1.5 squared minus 1. That's going to tell me what that value is. So we're not doing slope of the tangent anymore. We're just figuring out what's y reaching as I pick different values for x, and I got a 0.4. One value doesn't tell you anything. When I plug in 1.1 right there and right there, well, all what I have to do on my calculator, take 1.1, 1.1, and input it. Now that's stored in my answer. When I recall the function, guess what? It's going to take 1.1 minus 1 divided by 1 squared minus 1, and that's going to give me 0.476, 0.476190. And this repeats. Well, guess what? I'm in good shape because I logged the first number. What if I use 1.01? Well, let's see how that works. Where's the calculator? Oh, come on. Oh, it erased everything. I touched it with my stylus. This calculator is very sensitive. So I'm going to take 1.01, and now it's stored in my answer. But there's nothing because it's reset, so I have to do it again. That's okay. Answer minus 1 divided by answer squared minus 1. And I'm getting 4975, 124. Let me double check the previous, make sure I didn't make a mistake. 1.1. 0.4. Okay, very good. Now I'm going to take 1.001 and see what I get for that. 1.001. There it is. If I recall that, I'm getting 0.499, 0.499, 750. And let me take one more just to be safe. Again, these are not going to take us that long anymore. So if I take 1.0001, and if I recall that function, 4 3 nines and a 7 5. Well, if I was to say, hey, now notice we picked points from the right. So the way we write this, we say the limit as x approaches 1, and I know this is not something you're used to, but we're going to get used to it. 1. Do you notice we picked 1.5, 1.1, 1.01? Do you notice we're picking values to the right of 1? That's how we write it. Of x minus 1 over x squared minus 1. What do you think that number is if you round it? Isn't that like a 0.5 or a half? Okay, now what? That's not enough. We pick points above and points below. Let's pick points below. This is x, and this is x minus 1 over x squared minus 1. Below, this is 1. So if I go 0.5, then 0.9, then 0.99, then 0.999, and again, now that I know the bottom is 0.5, I'm seeing if the top is going to be 0.5 again. And if they match, I'm in good shape. If not, then we'll talk about what that means. Now, the formula is still there. Nothing changed. All what I have to do is take 0.5 and recall the function and see what happens. What do I get? Oops. 0.6, 66666. All of these sixes. Okay, well that's good. That's close to 0.5. First number doesn't mean much. How about if I get closer to 1.9? Enter. Now it's stored in my answer. Recall. And I'm getting 0.5263. 15789. 15789. Oh, it touched it again. Reset. Again, I have an issue with the calculator. Doesn't like it when my stylus touched that. How about 0.99? And again, there it is. But now I have to improve again because minus 1 divided by answer squared minus 1. So this is different than what we did before. 5025. 5025, 1256. Okay, well, how about 0.999? Again, very close to 1. 500, 500, 250. Well, I'm confident it's a 0.5, but let's do the last one since I already put it there. Point 5000. 2500. So my guess, again, here I'm picking points to the left. Do you see that? So here I would say the limit as x approaches 1. Since I'm picking points to the left of 1, I put left of x minus 1 over x squared minus 1. I'm going to say that's a 0.5. Since the numbers match, my conclusion is that this is how I write it. The conclusion out of all of this is that the limit as x approaches 1 of x minus 1 over x squared minus 1 equals a 1/2 or a 0.5, whichever you prefer. It doesn't really matter. And that's the idea of a limit. So let me put that in a definition. If f of x is defined where x is near number a, then the limit as x approaches f of x equal this number L in the previous problem. The limit as x approaches 1, which is a, of f of x, x minus 1 over x squared minus 1 was 1/2. That's L. We say the limit of x approaches a equal L. Means if we choose x values very close to A in the previous problem that was a 1 on either side from the left and the right, but we never use 1, then the y values will become very close to 1/2, and that's exactly what happened on the previous left and right. And that's the idea of a limit, which is a very challenging idea in calculus. I want to do 2 more really quick. There's x, and there's x to the 5th plus 1 over x to the 9th plus 1. Notice that's what I'm going to put for answer. They want us to approach -1. Well, let's see. There's -1. And it doesn't matter where you start. If I start on the left, this is 0. This is -2. I'm going to say -1.1, -1.01, -1.001, -1.0001. Let's see what happens if I do that. So I'm going to go in and take negative, and make sure you use that -1. Some calculators, they're not that picky. Some calculators give you an error. Now if I go in and I plug in that formula, and the formula is going to be parentheses, it's going to be that number to the 5th power, and there's the 5th power, plus 1, close parentheses, divide that by that number raised to the 9th power. Some calculators have x to the y to raise that power, plus 1. And see what happened then. I'm getting 44,958. That's fine. Then I'm going to take -1.01, see what happened. This negative again, 1.01. And if I recall the function, and I'm getting 544,483. 544,483. Okay, not bad. It wasn't that close, but it's okay. One value never gives you. You need a couple of values for this to work. And how about if I take -1.001? What would happen then? And if I recall the function, 55 4 fours. Okay, that's pretty good. I got it locked to 0.5. And what if I take -1.0001? And if I recall the function, 3 5s, and what else? 3 5s and multiple 4s. Well, let me just pick one more. Let me pick 4 zeros. Again, it doesn't take that long anymore. Four 5s. Okay, well, now I'm confident what it is. Again, I don't need that. I could have said, my guess, it's 0.56. So, since I picked points to the left, I could say the limit as x approaches -1 from the left of f of x is 0.56. Okay, how about points from the right? X and x to the 5th plus 1 divided by x to the 9th plus 1. From the right of 1, I'm going to go 1.1. I'm sorry, it's negative. I forgot it's not positive. From the right of -1, people, if I'm coming from the left, isn't that -0.9, -0.99, -0.999? Now it's not as bad as before. Why is that? Because I already have a value I'm getting closer to. So same function. If I take -0.9, enter, it stored that in my answer. Go to that function, 0.6685. 0.6685. You could take more decimals if you need to. 0097, doesn't matter. Now if I take -0.99 and I recall it, it's 56,670. That's good news because the ordinate should be about 0.55. It's getting there. How about if I take -0.999? Oops. There it is. And if I recall the function, 55 3 6s and a 7. 55, 3 6s and a 7. Very good. And if I take it one more, then pretty much I'm confident I don't have to do that anymore because I have the other side to really work with. But just for practice, point 1, 2, 3, 4. 3 5s. So my guess is the limit as x approaches -1 from the right of f of x is also 0.56. So I would say this is 0.56. And I'm going to do one more again. We need to practice this as much as we can. If I take 0, well, 0 is quick. If I go from the left, t or x, 3 to the t minus 1 over t. So again, the variable is right there. That's what I'm going to put for answer. I'm going to start from the left, negative 0.1, negative 0.01, negative 0.001, and I'll see if that's enough, negative 0.0001. Let's see how that works. Now I'm going to take negative 0.1. It's stored in my answer. Now I want to go in and input the new function, 3 raised to the answer minus 1. Notice we never use 1. Oops. We never use the actual value or 0 or whatever it is, divided by my answer. 1.0404, 1.040415. Okay, how about if I go a bit closer? How about if I take negative 0.00, no, 10. Okay, what would happen then? 1.092, 1.092, 59958, 59958. Okay, I got it locked to 1, that's good. What if I go for a negative 0.0001? What would happen now? 1.098, 1.098009. Okay. Good news. I locked it at 2 decimals, maybe one more. Negative 0.123 and a 1. There we go. And if I figure that one out, 1.098, 1.098, 55. I'm going to go one more. 4 zeros and a 1. Just to me, oh, it's reset. Again, I touch it with my stylus. So if I take negative 0.1234 and a 1, and if I have to reinvent it again, 3 raised to the answer minus 1 divided by answer. 1.0986. Well, if I round this, if I take the limit as t approaches 0, and I picked them to the left, right? I picked negatives. So from the left of f of t, you could write it out, 3 to the t minus 1 over t. It looks like it is going to be about 1.1 if I write it properly. What if I go from the right? What if I take t and I take 3 to the t minus 1 over t, and now I take 0.1, 0.01, 0.001. I want to see if I can get the same value. If I don't get the same value, then that doesn't work. We say the limit doesn't work. But for now, we're picking specific examples where it does work for now, just so you could get an idea of how this works. The first number gave 1.16134. Okay, very good. Because it's close to 1. No, not 1. 123. Okay. And if I go for the second number, which is 0.01, 1.104 669 1, and if I go for 0.001 1.099 216, and if I take one more, again I'm almost confident now. Again, I have another value to check. I have another value to match, which is the left side, 1.09867. One point zero nine eight 6, 7. Well, hey, what does that look like? Isn't that rounded to 1.1? So I say that limit is 1.1. And there it is. And now we go ahead and put that in perspective. If f of x is defined when x is near a, the limit as x approaches a from the left, that's when we pick the negative 0.1. And for the negative 1, you know, when we are approaching negative 1, we pick negative 1.1. We say this is approaching limit from the left, right? And if we pick points from the right, we say that's approaching points from the right. And look at this star. We say the limit as x approaches 0 of 3 to the x minus 1 over x equal 1.1 if and only if the limit from the left gives you that 1.1 and the limit from the right gives you 1.1. Otherwise, they don't exist. And that's how it works. So next, I have a few examples to do. And let me see if I'm going to do them. Yeah, I'll do that in a separate video because I don't want the videos to drag. So we're going to stop here and I'll pick this up on the next video.